This field day is a little different. We're going to make you get muddy. I mean, if you really want to see what I'm showing you here on some data in your own eyes, and you can rate it yourself if you want to, we're fixing to walk some plots behind me here in a minute. All right? And so it's worth it. I can tell you it's worth it to get off the trailer and walk those plots for yourself. Okay? First thing I want to talk about, I guess I'll introduce myself. I'm Tom Barber. I'm an extension weed scientist with the University of Arkansas Division of Agriculture. Myself and Dr. Norsworthy and Dr. Scott have tests very similar to the one we're standing in front of right here across the state. And but this one is further along and it's better to show right now. The rest of ours are 2 to 3 weeks behind his. And so you're going to hear today on this field day a lot about dicamba. And I guess it kind of puts us on the spot somewhat, but we figure out, you know, we might as well just show what we got, and you can make your mind up for yourself what you think. A lot of work has been done with dicamba for a long time. It's new this year because we've got more crops that are tolerant. In the past, we've used dicamba for burn down products prior to planting, glyphosate-resistant horseweed control. That's one of the #1 recommendations for dicamba in the state of Arkansas prior to planting, okay? It's also labeled in corn. And so we use dicamba probably on a limited acre basis, I'd say, in corn, but we do use it. And generally it's lower rates than what it's recommended for in the extend crops that we grow this year. So the #1 question I get all the time, why are we having an issue this year? Well, you think about it. When you're spraying dicamba for burn down or in corn, when are we doing that? Earlier in the spring. It's cooler, okay? You're going to hear words like physical drift. You're going to hear words like secondary drift. You're going to hear words like volatility. Well, when we talk about volatility, what we're going to talk about here in a minute, that occurs when those temperatures increase, and especially the temperature of the surface of where that dicamba is hitting increases, okay? And so we're going to talk about those things as we go through this talk. The first thing we're going to focus on, though, is physical drift. And so the first study we're talking about, it's actually a field or two over this way. This is a stationary boom study. And so this study was set up to demonstrate the difference in boom height and nozzle, spray nozzle, okay, nozzle size, and basically droplet size. And so not everybody, this is a huge group, I understand that. But I know y'all can't all see this, but a picture's worth 1,000 words. Y'all that are close, basically that T-post was put right here. In each one of these plots, there were 7 treatments in this trial, 3 different reps, a graduate student at each post with a hand boom and a TTI 04 nozzle, okay? Everybody sprayed for 15 seconds. Air horn went off, everybody sprayed. Air horn went off again, everybody stopped. So this is after 15 seconds at multiple heights with different nozzles, okay? And so I'm just going to show you that at the end of the day, this first picture here, this is a medium droplet size flat fan. We use flat fans a lot, especially prior to Roundup Ready, because we got good coverage with our contact herbicides. Okay, when Roundup Ready technology came out, we didn't have to have all those fine droplets, so we used an air mix more type of air mix, AIXR, that type of nozzle to help reduce drift on Roundup. Okay, but this is that medium flat fan nozzle at 48-inch boom height, and you can see here the amount of dead plants we had away from that stake. And these are all at 2 meters apiece. These flags are 2 meters apiece, okay? All the way out, you can see flags way back there, versus a labeled application with a TTI nozzle, 24-inch height above the canopy. So ultra coarse nozzle, 24-inch height. This was with Extendamax, 22 ounces, 15 seconds. See the difference at least in the amount of dead beans? Not near as many dead beans over here. And of course that's why that has a label. So boom height matters, nozzle type matters to decrease the amount of driftable fines that we have coming out of our spray boom. All right, let's see if we can flip this without the wind messing us up. All right. All right, so here's some data off these studies. Again, stationary boom, this is the average distance of dead soybean plants. All right. Extend-A-Max, medium droplet, either 48 or 24 inches. I mean, that looks pretty rough, especially right here, okay? Large swath of dead plants. But even when we move to the Turbo T at 48-inch boom height, this is probably not going to separate statistically from this one. We haven't run statistics on this yet because we're not done collecting data, okay? Then when we move over to our 24-inch height, I mean, that makes a pretty significant drop even with the Turbo T, which is not a labeled nozzle, okay? But look here, TTI, 48-inch boom height, that's not different than that, all right? And so I don't think that will separate out statistically. So boom height is very important. Nozzle type that you use in your sprayer is very important to reduce the potential for physical drift, okay? Let's flip it one more. This is the amount of damage plant. So this is average injured plant distance. And I didn't tell you before, this is all in meters. This isn't feet. These are meters, all right? And so, again, our medium droplet, 48 inches, medium 24. For whatever reason, our coarse at 48 inches went further than our medium did when that boom was high. Again, at 24 inches. TTI, 48 inches, distance to damaged plants. I mean, to me, that pretty much tells a pretty good story that if we're not keeping our boom low enough, this is just when we're spraying for 15 seconds, okay? If we're not keeping our boom low enough, 24 inches above the canopy, all right, we have more potential for that physical drift of dicamba depending on how far the wind, you know, how high the wind's blowing and which direction it's blowing. So that's physical drift. Now, we did see some distance here, 35 meters, even with our labeled droplet applications, all right? So we had about 35 meters with the Extend-A-Max and a little further than that with the Ingenia. And I will say, I got this question when we were touring some other groups through here last week. You know, there was no drift retardant used or any of that thing used in these booms. It's just straight product, okay? All right. Any questions on that? I think that's my last slide on that deal. Any questions? Yeah, I don't know who said first. Who?
Yeah, so Ingenia, what does that equate to in feet? It's over 110 feet, right?
Yes. Over 120, over about 130 some odd. It's times 3 times plus a few more, plus a few more. I don't know that conversion in my head. Yes, sir. Good question. I did forget to mention it. The wind speed, it varied. We sprayed each rep at a time because of the amount of graduate students he had here. We only had 7. So we had to have 7 for each rep. And so the wind speed varied from rep to rep. And if I could take everybody through that, we'll walk 1 rep, and man, it was straight from the south, and you can really see the pattern real good. Then you go to the second rep, and the wind had shifted, okay? And so it was more of an angle. So the wind direction shifted a little bit during the time of application, and the speed differed a little bit based on the rep that was sprayed, but it never got higher than 4 miles per hour in any of them. So 2 to 3 miles per hour and that's a good point. It's just 2 to 3 mile per hour wind, okay, where that's moving. Is there another question before I move on? Okay. All right. Just to show you a couple more pictures, and I know not everybody can see it. This is the one we showed earlier. You know, you can pick out that pattern. There's a line right there. This is that medium droplet size, 48 inches, severe plant damage for a long ways, okay? The severity of the plant damage, I didn't put that on a distance chart here, but you can tell it went a long ways more severe damage versus the 24-inch height. I mean, just even with the medium droplet, height makes a big difference. And we're not recommending medium droplets. Don't take the wrong message here. Don't say I recommended a medium droplet, okay? That's not the message. The message is, number 1, droplet does matter, but number 2, boom height matters a lot. What's our average boom height as you see sprayers traveling across the state of Arkansas?
75.
Yeah, 60 inches, 6 feet. That's he knows. He's our application technologist. So, I mean, I don't see many sprayers that are spraying at 24 inches. You know, I see sprayers that are spraying up here. And I noticed Larry's in the group. He's nodding his head. They've got uneven terrain in Tennessee. Larry, what's y'all's average boom height?
Just so you don't knock the boom into the hill on the side.
Right, yeah. And so there's terrain issues with boom height. But that goes back to, at the end of the day, y'all, it goes back to the herbicide, which we're talking about dicamba herbicide. It goes back to the sensitivity of soybeans. And at the end of the day, it takes very, very little to cause symptomology. Okay?
On the flip side of that, you separate from dicamba, when you double your boom height, based on some data we've looked at this season, you also cut your coverage in half. So you're
very good point.
all of that droplets, if you're not talking about dicamba, so with the Liberty, when you raise your boom height by double, you cut your coverage in half also. So we're losing ground on that side.
These nozzles, and y'all, the nozzle guy can correct me over here, but these nozzles are produced, our broadcast nozzles, to overlap at a certain point. And if you're not overlapping at that point, you're not getting the coverage right that you need on whatever you're trying to kill, whether it's a weed, an insect, a pre-emerge herbicide. It makes a difference there too. You've got to adequately cover the soil to be effective. Okay. Any other questions? All right, we're going to move to the study I have behind me here. Now, we've got a little tent set up for demonstration, but this is a volatility study. I told you you're going to hear a lot about volatility today, because it doesn't matter how much I control physical drift. I can, is there tank contamination issues out in the state this year that caused issues? Yes. Did physical drift cause issues? Yes. All right, somebody name another one that you've heard. Contaminated glufosinate, is there any of that? I don't know. But I can tell you for sure, none of that matters if all of them volatilize. What does it matter if I spray it as good as I can and they get up and walk on me? I can't control that. All right? So that's why this study was set up. And before I forget to mention these points, a lot of work has been done both internally with the companies and externally with humidomes. All right? Humidomes are great for looking at the amount of dicamba that's volatilizing and measuring it at a level and comparing it. And when you do that and you look at the numbers, you look at the amount volatilizing from one formulation to the next, there's a lot of differences there. But nobody can tell me, I challenge anybody to tell me today, what level of volatility I have to damage a soybean plant. How low does it have to be before I get damaged? Anybody? I don't know any data out there. No, it's lower than that. We get damaged with 1/100,000. It ain't much. And so comparing volatility work in a greenhouse and a spray chamber is not the same as me putting it out here in some soybeans. It's not the same. At the end of the day, that's what all the data says. Okay? So, we set up hoop trials. This is done at 3 locations across our state. This is a regional study as well. Several other states are doing this. A hoop is set up. We can look at it here in a minute. We're fixing to walk the field. It's going to be a challenge with this many people, but y'all need to see it. I want y'all to see what data we have. All right, so y'all can all just say, no, they're not crazy. They really have data to back them up, right? So anyway, we got trays inside the tunnel. What happens is we got greenhouse trays. We filled it with dirt from the field, went back, sprayed it up there at the lab area, brought them back to the field, set them in the tent for 48 hours. So they were set in the tent 48 hours, in the little greenhouse tent there, and the soybeans were around V3 when this was done. Okay? V3. All right. We're going to show you a little data, then we're going to walk the plots. So these are the treatments that we put out. Banville plus Powermax. And you've heard a lot about dicamba and different salts. I don't want to wade down too much in that right now, but we can. If you want, Banville's a DMA salt, one of the first ones. They put the salt with the parent acid in order to reduce the volatility and to make it mix better and that kind of thing in the plant. All right. Clarity, again, is a diclycoamine salt. Ingenia is a new salt from BASF. Extendamax is basically a DGA salt like Clarity with the vapor grip technology. All these were mixed with Roundup. Then we put an Extendamax plot with Roundup and ammonium sulfate. All right. Is that a labeled application? No. The reason that's not labeled is when you put ammonium sulfate in with any of these dicamba formulations, it disassociates that parent acid from the salt. And when that happens, the parent acid is going to readily volatilize. And you're going to see that out here if you'll walk the plots. Okay? Temperature, I know I'll get a lot of questions. What's the temperature and that kind of thing? So blue line's temperature inside the tent. We set up a weather station out here. The red line's temperature outside the tent. We did get some spikes in the middle of the day. This is over that whole 48-hour period that we ran the study, okay? For some reason, my axis over there got chopped off, so you can consider this percent humidity as well for the green line. All right, more or less. So that's our humidity levels during the test. And I'm not going to spend a lot of time talking about that, but the point is it's hot enough to cause dicamba to volatilize, okay? What's more important, really, a lot of times than the air temperature is the temperature where that mix is applied or where that dicamba is applied. If it's bare soil, it's the temperature of the soil. If it's vegetation, maybe the temperature on that leaf where it's sitting. And that temperature is going to be, depending on what that temperature is, will determine whether it will change from a liquid to a gas or a dry to a gas, okay? But the dicamba formulations can do both and go to a gas from either state. Here's the data, and then we're going to walk through the plots. All right, our untreated. We have an untreated. It's the first plot. It had some dicamba injury on it. Now, there hasn't been a soybean plant that I'm aware of in some of Jason's research here on the station that hasn't had dicamba injury at some point in time. Matter of fact, all of this work we're talking about today had to be replanted because of the amount of dicamba injury that it received. These are a lot slighter. It's a very, very low rate, but you can still pick it up. And we rated it about 3% in our untreated checks. Now, all this data is preliminary. No stats have been run. It will get, rated again this week for a 21-day rating. So this is percent dicamba injury on the soybean plants. The blue bar represents row 2. I separated it out because as you walk through these plots, you're going to see a little more damage on row 2 or the row to the right of the stake than you will the row to the left of the stake. Okay? And then the red bar is when we averaged it across both rows and all 3 reps. So the trend stays the same. The damage is just decreased a little bit when we do the averaging. So Banville's here. Clarity's here. That might separate statistically, but Clarity, Extendamax, Ingenia with Roundup, PowerMax 2, I don't think when I put stats on that, at least at this time, and that's going to separate. Now, we've got more injury. I'll tell you, there's more injury in those plots today than there were last week. So we may see some more separation with at least with the Banville plots. AMS, is that a big no-no? Yes, it's a big no-no, okay? And so that goes back to another point I want to make before we move on. These products on these websites for EPA registration in regards to tank mixing, the products that are on the website in regards to tank mixing, to my knowledge, the only thing the EPA required for those tank mixes are droplet studies to determine the percent of driftable fines after you mix those products. All right? Has nothing to do with it changing volatility of the dicamba formulations. All right? And so anything you add to that tank, potentially, doesn't mean it's going to, but that's the thought process we need to get into. Anything we add to the tank, if we're spraying any of these formulations, could increase the volatility. And we don't need increased volatility. We're getting enough already. Okay? All right. Here's another trial. It was done earlier. This is 21-day data where the products were just applied by themselves without the inclusion of Roundup. We really can't compare this data to the other data because of different timing, different environmental conditions. But trends are very similar. We see less damage with these two formulations than what we saw in the other tests when we added the Power Max. This is a metolachlor plus XtendiMax premix. And this is an interline, which is a glufosinate or Liberty formulation with XtendiMax. Now, what is glufosinate? If you look it up on the label, it's glufosinate what? Ammonium. Okay? All right, so anything that has the word ammonium in the label, I'm venturing to guess we probably don't need to mix it from a volatility standpoint anyway. Okay? All right, we're fixing to look at some plots. Yes, sir. Okay, so we sprayed, these were actually sprayed earlier. These were around V1. These were around V3. And then so you've got 14 days and 21 days after that. I think these are still in the vegetative stage. I didn't see a bloom when we walked through there the last time. I don't know. I doubt the plan is to take it to yield. I mean, we could, I guess, but I don't know if that's the plan right now. Yeah.
Why did row 2 have more damage than row 1?
That's a great question. I don't know, but it's at every location. And I don't know if it's the way when that wind hits that tunnel, if it moves in this circular fashion and then it just deposits more on row 2. But that's my guess, but I don't know if that's really what's going on. You can see injury on both rows. It just seems a little worse on row 2. Okay? All right. So what we're going to do, and I'd like everybody to do this, whether you got mud boots or not, if you're interested in knowing what it looks like in the field, I want y'all to see this. You can look at the demo first. Now here's another thing. So the front of the plots, those all white flag? Yeah. All right. So the first red flag, there should be a stake. From that stake onto the back red flag, try not to walk through the plots because we're still rating these plots, okay? So let's walk around the plots, but I want everybody to get an idea. And remember, since it's going to be impossible for everybody to see them at the same time, our untreated is right here. So untreated, you're going to see a little bit of damage, not bad, about 3%. Then we've got Banville next, Clarity next. Then I think it was Ingenia, then XtendiMax, and XtendiMax plus AMS. All right? All right, and then we had the Roundup Extend formulation was the last one. Okay? So let's walk through some of this.